perspective, where we look at landscapes and study landscapes as complex, coupled human environment systems, recognizing that what we see on a landscape is the outcome of centuries of interactions between humans and that natural environment that we inhabit. And when we think about landscapes in this way, then the concept of ecosystem services becomes a very useful way to operationalize that coupling between humans and our environment, because it really speaks to what we get from ecosystems. It's a very anthropogenic concept, and it's related to, or it can be defined as, the benefits that humans obtain from ecosystems. But it really speaks to how humans interact with the functions and processes, the natural functions and processes on our landscape. And so that's the framework that we've chosen to work within. And when I think about ecosystem services provided by a landscape, I like to look at them. Oh, pardon me, I forgot to give you my list of ecosystem services. In fact, Dan did a really good job of this morning. So when we talk about ecosystem services, we tend to speak of them in terms of supporting services, regulating services, provisioning services, and cultural services. And these are examples of some of those things that fall into those different categories, and which our landscapes provide to us. And they provide them to us essentially for free. Most of these things are things that we take for granted, that are essential to our health and well-being and our livelihoods, and yet we often aren't considering them in our larger management contexts. And so when I think about a forest ecosystem or any ecosystem, I like to think about the services that it provides by looking at it as flowers on a petal, where petals on a flower, sorry, it's the end of the day, where each petal could be one service. And then the size of that petal could be the degree to which the particular ecosystem or landscape provides that service. So this is an example of some of the ecosystem services that forests provide to us. And in an ideal forested landscape, all of those petals would be completely full, and our forest is providing us with habitats, which are different supporting services for biodiversity, timber, aesthetics and recreational opportunities, water filtration, water flow regulation, opportunities for food gathering and foraging and hunting, as well as rangeland. And there are, of course, many other services. I could add more petals to this flower. Now, on the flip side of this are humans and our demand. So we can think also of what are we asking of our ecosystems. And that depends on our management context, and it depends on the part of the landscape that we're talking about. So for a national park, for example, we might not be expecting timber production, or that's not a service that we would be expecting to extract from that particular ecosystem. But we might have high expectations for that ecosystem to provide us with tourism and recreational opportunities, or with landscape aesthetics, or water quality and filtration services. So we can think about petals on the flower in terms of our demand for ecosystem services as well. And if we move into a working forest, well, the size of those petals might change, because our expectations of a working forest are different from our expectations of a forest in a national park. And here we might have expectations for timber production, but lower expectations in terms of the ability of that forest to provide us with recreational opportunities. And so at the landscape scale, what we're seeking is to find the correct balance between the landscape's ability to provide us with ecosystem services and our human demand for those services. And so I tend to look at it like this. This is the ideal situation, where we have, at the landscape scale, a landscape that is providing us with a full collection of ecosystem services, and our human demand for those services does not exceed the capacity of the landscape to provide. And that, for me, is the definition of a sustainable landscape, one where humans are living within the footprint of the ecological footprint of that landscape by not extracting more ecosystem services than that landscape can provide for us. And landscape resilience I define as the difference between the ecosystem's ability to provide services and our demand. So it's the blue part of those petals that aren't covered by red. That's the room we have to maneuver. That's our landscape resilience. And so when a disturbance comes along and reduces the size of one of those blue petals, if our human demand is low enough, then there's room to maneuver. If that disturbance reduces the blue petal so it's smaller than the red petal overlying it, that's where we get into trouble. That's where we see loss of resilience and loss of ability of the system, of the natural system, to recover and respond, unless we as humans intervene and take management efforts to also reduce our demand, reduce the size of the red petal to allow the system to recover. And so thinking about it in this way, then what happens when a mountain pine beetle outbreak comes in? Well, it affects some of those blue petals, at least for the short term. It might affect timber provisioning. It might affect other abilities of the ecosystem to provide some of those ecosystem services. And so our management efforts should be directed at looking at where can we intervene in the red petals. Can we or should we be reducing our demand in particular areas to maintain resilience of that ecosystem and to allow it to recover within its ability to do so? And so coming back to the flower, then as a mountain pine beetle outbreak comes in, we can envision that some of those blue petals might be changing in size, and then some of the red petals might be changing too. And we might actually be shifting. I mean, in a real situation, all of those red petals might not be equal in size. If we were dealing with a working forest, we might be shifting our expectations of timber production after mountain pine beetle outbreak to some other ecosystem service that might continue to be offered by that system, and we might actually adapt our use of the forest to accommodate the ecosystem's ability to provide those services. So that's the framework that we've been working within. And the first part of the Theme 4 research was led by Dr. Amalesh Dhar, who was a postdoctoral fellow with us for the first couple of years. And he started looking at what is known about how mountain pine beetle affects ecosystem services. And a whole collection of work has been done on different services. Very few people had actually brought all of that work together. So one of the biggest contributions that Amalesh made was to actually synthesize and bring together a large body of work on the possible impacts of mountain pine beetle on ecosystem services. And as you might expect, timber is the most impacted service. That's the one that we hear about all the time. But water flow regulation is another one that seems to be impacted. And I'm going to show you a slide that I threw in here after, I think it was Dan this morning, showed the title of a paper that said that stream peak flow is not impacted by mountain pine beetle in the western US. So that may be true, and it may be true for Canada too. But here's kind of a back of the envelope bit of work that Amalesh did, where he looked at over 200 stream flow monitoring stations in the province of British Columbia and looked at peak flow before and after the mountain pine beetle outbreak. And what we see here is each point is one of those stations, and the dark green are stations where peak flow has increased over that period, and in some cases increased more than 35%. And that's in a context where precipitation and winter snowpack did not increase. And so while I would be the first person to say this is not cause and effect, and we cannot say this is caused by mountain pine beetle, we are likely in a case where clearly something is going on with forest hydrology in these watersheds, and we're likely in a case similar to what Chris Stockdale was describing this morning, where there are a whole lot of interrelated factors happening on the landscape related to vegetation change because of mountain pine beetle, fire, human management, land cover change, and climate, all interacting together. And while mountain pine beetle may not be causing increases in peak stream flow, it is probably part of that equation. And coming back to some of the other things we've been looking at, biodiversity is a difficult one. The impacts on biodiversity vary enormously, as you might imagine, because some species benefit, some don't. Studies done in British Columbia suggest that the tourism and recreation sectors are not significantly impacted so long as trails are reopened quickly and camping sites and things are reopened. In British Columbia, none of the provincial parks or rec sites or national parks, Kootenay National Park, none of them saw a decrease in visitation rate after the mountain pine beetle outbreak. So as soon as sites were open again, people kept coming. And lastly, in terms of impacts on most ecosystem services, they are interrelated with how we respond in terms of management response. And many of those impacts are greatly changed when we go in and salvage log after, because then we're changing, impacting soils, changing the vegetation cover significantly. So there are lots of confounding impacts that make it very difficult to say precisely how mountain pine beetle affects a particular ecosystem service because it's interrelated with so many other things. Now, what about the human side of the landscape? Well, the human communities sit within this larger context of our natural capital. As mountain pine beetle comes in, is it affecting that natural capital? And then the kind of social and human and built capital that's available to human communities affects their ability to respond or to adjust the size of those red petals. And so the other students working on this on theme 4 have been looking at the human side and the human response that is possible to mountain pine beetle outbreaks. And some of the first work that was done was by a postdoctoral fellow, Rodolphe Gonzalez, who did some social network analysis for the communities of Jasper and Hinton as a way of looking at the preparedness of those communities in terms of their ability to exchange information and interact with one another about the outbreak. And he produced a network of interactions. This is the social network for Jasper and Hinton, where each node is a person and each link is information exchange between people, and the colors of the nodes correspond to the organizations to which people belong. And by looking at this network, we were able to identify areas of weakness, for example, organizations that perhaps weren't sharing information as well as they could, as well as identify strengths within that network and that are opportunities and which will help those communities react, adapt, and respond as the mountain pine beetle comes in. Other work that is ongoing is work by PhD student Matthias Bass, who is rendering networks like these dynamic. And so he is developing dynamic models of social ecological networks where he has social nodes and ecological nodes in interaction, and he has rules for those interactions, and he's looking at what are the structures of social ecological networks that make them resilient and robust in response to disturbances like mountain pine beetle. And Rob Freiberg, who presented this morning, is continuing this work with Jasper and Hinton and also Grand Cache, doing a qualitative analysis of their abilities to respond to mountain pine beetle and developing a framework for resilience that can be used and applied to communities to help them structure their thoughts around how they might be prepared and for mountain pine beetle or other disturbances and be ready to respond. And what's coming out of all of this is what you might expect, which is that the more resilient communities are those which have sufficient social and natural capital. It's a combination of both. And so they require healthy, functioning ecosystems. Those blue petals need to be there. And it also requires engaged and informed citizens. Often there's a champion in a community that leads things forward, that helps a community mobilize and be better able to adapt, transform, respond in times of change. Communities need to have the ability to leverage their natural and social capital, and that happens through interactions, through those formal and informal social and institutional governance structures. And those are the kinds of things that Rob is looking into in more detail, and which are also coming up in Matt's modeling work, because what is showing up in even the theoretical models is that the more connected a community is, the better able it is to respond. In that, even if sometimes those connections are very weak, When they're there, they can be leveraged. They can be used to exchange information and resources when required to respond and to be more resilient. And so in terms of management, my first take-home message is one that would apply across any forested landscape in Canada, even outside of the mountain pine beetle context, which is that we really need to adapt our approaches to management to think about all of the petals on that flower, to think about the landscape as a complex, coupled, interconnected human environment system, and to develop new management approaches that don't just work on one piece, one petal at a time. We need to start looking at the whole flower and how and what our impact is in terms of those red petals. Any responses of communities to mountain pine beetle may involve transformation and adaptation, depending on the degree to which that community is affected and their dependence on the forest sector. And any response will by necessity be context and place dependent, because each community is different. There's no single solution that will be broadly applicable across communities, but each one will have pieces of that puzzle that they can pull together in their response as they adapt and transform as required. And so I'll stop there and thank you and welcome any questions.